Hi, year 11s and 12s. Today we're looking at our third video in our photosynthesis subtopic of Unit 8, which is Metabolism, Respiration and Photosynthesis. This is a video for the IB diploma. This is a HL topic. So we've just talked about light-dependent reactions. Now we're going to focus on light-independent reactions in this video. So like light-independent reactions are occurring three main steps. It's also worth noting as well that the light-independent reactions are also known as the Calvin cycle. And I know we've got another video coming up called the Calvin cycle. We'll get to that in a second. But light-independent reactions, also known as the Calvin cycle, occurs in three main steps. The first is the carboxylation of ribulose biphosphate. The second step is the reduction of glycerate 3-phosphate, and then the last step is the regeneration of ribulose biphosphate. Now again, remembering this is a cycle, so this is a continued along. When we talked about the difference between chains and cycles in our very first PowerPoint on metabolism. So when we're talking about light-independent reactions, this is a cycle. So let's start with our very first step in our light-independent reactions, or our Calvin cycle, which is carbon fixation. Now, carbon fixation begins with a 5-carbon compound, which is ribulose biphosphate, or RUBP, which is labelled here, and we can see that down here, RUBP is a ribulose biphosphate, which is a 5-carbon compound. Okay, and we start with 3 of those. Okay, and an enzyme, RUBP carboxylase, will catalyse the attachment of carbon dioxide molecules to RUBP. So we've got our 5-carbon molecule here, we've got 3 of them, and we've got 3 lots of carbon dioxide, so 1 carbon dioxide attached to each RUBP, which is going to create a 6-carbon compound. Now that 6-carbon compound is really unstable. So it breaks down very fast to form 2 3-carbon compounds called glycerate 3-phosphate, or GP. Okay. Now, because we're using 3 molecules, and each one of these molecules will break up into 2 3-carbon compounds, we end up with 6 molecules of glycerate 3-phosphate at the end of carbon fixation. Okay, so at the end of step 1, we've ended up with 6 molecules of GP. Moving on to step 2, which we're looking at over here. Okay, we're going to convert our molecules of GP into triose phosphate, which we're labeling as TP. Now this is done through NADPH and ATP, which we generated in our light-dependent reactions in our last video. Okay. The reduction of these NADPH transfers hydrogen atoms to the compound, while the hydrolysis of ATP will provide energy for this reaction to take place. Now each GP molecule that we are going through requires 1 NADPH and 1 ATP to form a triose phosphate. So each one of these cycles requires 6 of each molecule, so 6 lots of ATP and 6 lots of NADPH in order to reduce glycerate 3-phosphate into TP at the end of step 2. Okay, and because we started off with 3 molecules of RUBP, each one was broken down into 2 molecules of GP, giving us 6 molecules of GP. Each one of those needs its own, each molecule of GP needs 1 ATP and 1 NADPH, so we need 6 lots of ATP and 6 lots of NADPH to be reduced to end up with our TP at the end, or our triose phosphate at the end. Okay, which triose phosphate, just for noting as well, is also a 3-carbon compound. We then move on to step 3, which is our RUBP generation. Okay, so of our 6 molecules of TP produced per cycle, one of those TP molecules may be used to form a half sugar molecule. So we can see over here is breaking off one of those creates a half sugar molecule. Okay, so that means we need 2 cycles required to produce a single glucose monomer, and even more to produce polysaccharides like starch. So we need to go through the entire light-independent reactions twice to create 1 single glucose monomer. Our remaining 5 triose phosphate molecules, though, are recombined so that we can regenerate RUBP, so that we can continue this cycle over and over again. Okay, so from this whole cycle, even though we've created 6 molecules of TP, only one of those is used to make half a sugar, and the other 5 molecules are used to recycle to make RUBP again. Now that works because we've got 5 lots of 3-carbon compound products, and we're going to recycle those to make 3 lots of the 5-carbon compounds. So the maths works out there. Now, in order to do this, we need energy to work, so RUBP, that's requiring energy derived from the hydrolysis of ATP. We're going to end this video here, so we can talk about the Calvin cycle in a little bit more detail in the next video.